Hello students, welcome to the lecture number 6 on hydrocarbons. We are basically discussing these hydrocarbon chapters, and so far we have discussed different topics in this chapter. Like in the first lecture, we have discussed about the alkane. Alkane is basically a saturated hydrocarbons where you will find it's a carbon-carbon single bond. In the second lecture, we have discussed about the properties of the alkanes. In the first lecture, we have discussed that is the preparation of the alkanes. In the third lecture, we have discussed about the preparation of the alkene. Alkene is basically unsaturated hydrocarbon that we will understand that there is a carbon-carbon double bond. In the fourth and fifth lecture, we have discussed about the properties of the alkanes, that is the physical property and the chemical properties. We have spent 2 lectures on that. So this is lecture number 6. In this lecture, again we are going to discuss a very important hydrocarbons, that is the alkyne. Alkyne is basically like alkene. This is the unsaturated hydrocarbons. In alkene, we found that there is a carbon-carbon double bond. In the alkyne, that we have seen that the nomenclature, isomerism and preparation of the alkene. 3 different topics that we are going to discuss, which is included in your syllabus. This is K.K. Mukherjee, the Science with Mukherjee Sir YouTube channel. So let us understand first the general formula of these 3 hydrocarbons that we have discussed about that in relation to this, that we know the alkane have the general formula. Alkane, you have the general formula, that is CnH2n plus 2. What is N? N is basically the number of carbon atom present in that hydrocarbon. For alkane, which is saturated hydrocarbons, you will have this general formula. In alkene, that we can see it have the general formula is that we know there is a carbon-carbon double bond, so there will be the least number of hydrogen atom, and that is -2. So when we make this general formula, it will be like this. So what is happening in the alkane? The carbon atom becoming same, but hydrogen atom goes on decreasing. And in case of alkyne, what will be its general formula? Again, there is a carbon, at least carbon-carbon triple bond. Here is a carbon-carbon double bond. You can write this carbon-carbon double bond is a carbon-carbon single bond in the alkane. In the alkene, carbon-carbon double bond, and the alkyne, it is the carbon-carbon triple bond. So here also you will be observe that there is also the less number of hydrogen atoms as compared to this alkene. It is CnH2n minus 2. Alkyne is a very important hydrocarbon in the sense that it can be used as a starting material for the different organic compounds. You can produce different organic compounds as per example, that you can prepare alkane from this alkyne, you can prepare alkene from this alkyne, that we have discussed in the preparation part. You must have watched this lecture. So alkane is a very important hydrocarbon, so we have to study these hydrocarbons in totality. That is, first we are going to discuss its nomenclature. Nomenclature is basically, you know that it divides into 2 parts. Nomenclature is basically divided into 2 parts. That is the common name, because every compound have a common name, and also it is having the IUPAC name, that is the official name. So we are understanding in regard to different types of compounds, alkynes. That is, first we take, that is the number of carbon atom. Number of carbon atom. Number of carbon atom, that is, suppose this is N, and in that number of carbon atom, from that we can able to make the formula of this alkyne formula on the basis of its general formula. Then we will have the formula, then we have the structure. Then we will discuss the common name. C means common, and IUPAC name. Okay, so let us understand the nomenclature of the alkyne, right? We will take some different compounds and we will understand it. First, that is the first member of this alkyne family is the, when the carbon atom in the hydrocarbon is 2, that it starts from the 2, right? Its formula will be naturally C2H2. We will just put this value 2 here. Why will you find 2, 4 minus 2, 2. So C2H2. And its structure will be this, because it is having the triple bond. The structure will be this, and you can find the carbon valency, tetravalency is satisfied with this inclusion of that triple bond. Okay, and its common name is acetylene. Acetylene, or sometimes it is called acetylene. Acetylene. IUPAC name is basically derived from the parent hydrocarbon, parent alkane, from which this has been produced. So alkane, that is, you can see as it is a 2 carbon atom, means it will, name with the alkane will be ethane. So ethane, in this ethane word, this is the ethane word. Suppose this is the ethane word, this is the alkane, but the name of this alkyne will be derived by replacing this ane by a suffix. This is yne. So name of this compound, that the first member of this family, that is, it will be ethyl, right? So we understand acetylene is common name and IUPAC name is ethyl. Second, that is when the carbon atom is 3, at that time its formula will be C3, and we will put again this value, this 6 minus 2, the C3H4. So its structure will be this CH3, C triple bond CH. So we have to always consider, when we are constructing the structure, that we will consider this valency of the carbon, that is 4. So here you will find the valency of the carbon has been fulfilled. That we have to always remind that the carbon valency is 4. So here the common name of this compound will be, that it will be always considered as a derivative of the acetylene. Derivative of the acetylene means the one of the hydrogen atom, this is the acetylene, one of the hydrogen atom is replaced here, you can consider replaced by this methyl group. So we can name is methyl acetylene. Methyl acetylene. This is the name, common name of this compound, and its UPAC name is, the hydrocarbon is propane, so its name will be propyne. Okay, so when there is a 4 number of carbon atom, at that time its formula will be C4H6. And you will find here in this compound you will find there is a two structure, not only one, there will be two possible structure. One structure is this, and this name is dimethyl, because there is a two methyl group, dimethyl acetylene. Okay, dimethyl acetylene, and its name will be, as it is a 4, so name of this but2ene. Here you can see in the chain the triple bond is at the second position of the carbon atom. The carbon 1 at 1 position, 2 position, 3 and 4. So in the second position this double triple bond is there, so it will be but2ene. And this compound will have this another structure, because we can shift this triple bond. It is not like it will be in the second position, it can have in the first position also. See, when you are constructing this structure, you can always count this hydrogen also. You can see hydrogen 5 plus 6, it is 6. Hydrogen is 4. So you have to always count the hydrogen. So you will be able to have the correct structure of this. So what will be its name? Its name, common name will be ethyl, because here group you can see that is ethyl acetylene. Ethyl acetylene. Ethyl acetylene. And name of this IUPAC name will be but1ene. So you can observe this compound, that is the butane. Butane compound have the two structures, and this is but2ene and but1ine, and this is called the position isomers. This is called position isomers. Right? In a similar way, you can see when there is a carbon atom is 5, when the carbon atom is 6, and so on, you will find there is a different structures and different isomers that we will now going to discuss. Most probably it has been you will be able to understand this, what I have tried to say, that is this nomenclature is basically governed, the common name is governed by the acetylene, that is the parent, that is the first member of this family, and it will be the derivation of this acetylene, that is methyl acetylene, dimethyl acetylene, like this way. And IUPAC name, we have to see the what alkenes, from which alkenes that is it has been produced, and from that we will be able to derive this by replacing that ANE word by YN. Okay, now we are going to discuss again the when carbon atom number is 5, how many structure is possible. When carbon atom number is 6, how many structure is possible. When number of carbon atom is 5, so at that time the formula will be C5H8. So at that time, how many structure is possible, let us understand. So first you can see this structure. This is one structure that you can see. Here you can see number of hydrogen atom. You can see the number of hydrogen atom 5. So name of this compound that you can see, that is pent, because hydrocarbon is pentane, so pent1ine. Okay. Another compound that you can see, we are just shifting this so you can see triple bonds there 1 2 3 4 1 2 3 4 5 5 and this carbon dot triple bond has been shifted to the second position. Here it is in the first position, now it is on the second position of the carbon atom. So name of this will be pent 2I. And this is basically the position isomer. This is position isomer. Okay. Now another isomer is possible in this hydrocarbon, that will be the chain isomer. At that time, what we will do, we will create a chain here. One, two, three, four, 5. So this is again one isomer, one structure of this pentyne. That is, this name of this num is 2, 3, 1, 2, 3. So this will be 3-methyl pent 1I. Okay. So this isomers is basically, we can see chain isomer. This is chain isomers. Chain isomers to these isomers, and these isomers, we will say this is basically chain isomers, because here it is a single chain, and here you can see there is a branching. One CH3 group has been branches in this compound. So this is chain isomer. Now we will construct when carbon atom is 6. At that time, how many structure is possible? When carbon atom is 6, at that time it will be C6H10, formula of this, and this will be hexane. Hexane will have, you will find, that is 7 structures. Let us have these 7 structure one by one. First structure, C, one, 2, 3, 4, 5, 6. So name of this is hex 1I. Right? Second structure, that we are shifting this triple bond from this first position to second position. Here you can see CH3, C, triple bond, CH2, CH2, where 1, 2, 3, 4, 5, CH3. So here you will find hex 2I. Okay. Third position, the third structure is CH3, CH2, C, triple bond C, CH2, CH3. So at the middle position you can see this triple bond, and this is name is hex 3Y. Okay. So these are all position isomer. These are all position isomers. 3 structure we have drawn. Now this is 4th structure that we will make is a branching. This is 3. See, we are branching. On branches we have been, then C, triple bond C, CH3. So this is another structure. Here you can count this carbon atom 1, 2, 3, 4, 5, 6. So name of this, we have to make the numbering from this nearest to this triple bond. That is nearest to triple bond is this carbon. So this will be 1, 2, 3, 4, 5. So it will be 4 methyl pent 2 I. 5th number, in this isomers we can shift this carbon triple bond to this position. So 1, 2, 3, 4, 5, 6. Now it will have the 4 methyl. This will have 4 methyl pent 1 I. And here also another isomers. That is 1, 2, 3, 4, 5, 6. On another 2 isomers you can also able to have. That was going to construct 6 number isomers. It is CH3, CH2, CH3, C, triple bond, CH2. 1, 2, 3, 4, 5, 6. So this will be 1, 2, 3. This will be 3 methyl pent 1 I. And 7 number of isomers will create the double branch. CH, C, CH3, C, triple bond, CH3. 1, 2, 3, 4, 5, 6. So this will be 2 dimethyl, 2 dimethyl but 1 I. So these are all 7 structures that we can able to see. So likewise, if there is carbon number of 7, that will be number of structures will be different. So you can easily construct yourself so that you can able to understand. Now this is a nomenclature and isomerism part. Now we will discuss its preparation. Hydrocarbon, that is alkyne, is prepared in 2 different ways that we are going to discuss. Number one, that is from calcium carbide. Calcium carbide. And this is a industrial process of preparation of the acetylene, that is CaCl2. And this calcium carbide has been prepared, that is also 2 ways, that is calcium carbonate, which is the limestone. It is also called the limestone. When limestone is heated, when we heated the limestone, it is going to produce calcium oxide and carbon dioxide. And this calcium oxide is called the quick line. This is called quick line. Quick line. And when it is reacted with the coke, this is a carbon, it will going to produce the calcium carbide and carbon monoxide. And this calcium carbide, when it is being reacted with the H2O, it is going to produce the calcium hydroxide and acetylene gas. Okay, this is the manufacturing process of this. This is the first member, that is the acetylene, or we can say ethyl. Okay. Secondly, second process by which we can able to prepare this, that is from vicinal halides. Vicinal halides, or we can say vis dihalide. How we can able to prepare? That is by treating with the KOH, which is alcoholic. Alcoholic KOH, when treated with the vicinal dihalide, it is going to first prepare the alkynyl halides, and this alkynyl halides, when further treated with the in sodiamide, and it is going to produce the acetylene. So we can understand this. It does have this reaction, CH2 Br, CH2 Br. This is 1,2-dibromo ethane, or we can say that is a vicinal halides. When it is reacted with KOH, alcoholic is very much essential, otherwise this reaction will not be happen. Alcoholic KOH you need. So here what is going to happen? KBr and H2O will be eliminated. Means one molecule of HBr has been eliminated, and it is going to produce this. It is going to produce the ethynyl bromide. This is ethynyl bromide, and this ethynyl bromide, when Na sodamide, this is sodamide, and this sodamide is also a ionic compound. This Na will take up this NaBr, minus NaBr, and minus N is 3. It is going to produce this ethane. Going to produce this acetyl ethyl. So we can understand there is two ways by which we can able to prepare this. So that is all for today's lecture. In this lecture we have discussed very important informations, that is the regarding the alkyne, that is isomerism, and this is nomenclature, and also we have discussed about its preparation. The two different ways we can able to prepare it. Thank you very much for watching, and we will meet in the next lecture with the properties of the alkyne.